Next, we're going to talk about division equations, but first we need to make sure we understand a little bit about notation. So in this example, I have x divided by 3. Well, x divided by 3 is the same thing as a multiplication problem. So see if you can figure out what x divided by 3 would be the same thing as. If you think that x divided by 3 is the same thing as x over 1 times 1 over 3, you are correct, because x divided by 3 is the same thing as x times 1/3. We have learned that division is the same thing as multiplying by the reciprocal. Therefore, x divided by 3 equals x times 1/3. And I just rewrote that as x over 1 times 1 over 3 so that we can clearly see the numbers in the numerator and the numbers in the denominator. So that is the same thing as x times 1 over 1 times 3, which equals x over 3. So what I've proven here is that x divided by 3 is the same thing as x times 1/3. Now, I'm going to rewrite x times 1/3 as 1/3 times x. Since this is multiplication, it doesn't matter the order we multiply in. And now, instead of writing 1/3 times x, we know we don't have to write the multiplication symbol when we're multiplying a number times a variable. That number becomes the coefficient, and we can just write this as 1/3 x. Therefore, x divided by 3 is the same thing as 1/3 times x. The way I see it, just quickly in my head, is I know that there's a 1 times x in the numerator, and I kind of visualize this as pulling the 1/3 apart from the x. And I can see visually that this is the same thing as 1/3 x. So let's look at another example. X divided by -6. Do you have an idea what this might be the same as when you write it using multiplication? Again, I visualize that there's a 1 times x in the numerator. So I have the fraction -1/6. Remember, the negative can be in the numerator or the denominator of a fraction, and it will give you the same value. So I visualize this as -1/6 times x, or -1/6 times x, -1/6x. So what about 2x divided by 5? What do you think that's the same as using multiplication? I visualize the numbers as a fraction and the x by itself. So this is the same as 2/5 x. This is important because I'm going to have you rewrite all division as multiplication so that you can work with the multiplicative inverse. So I want you to try a couple of these. Write each of these using multiplication instead of division, and when you're done, come back and see how you did. In the first problem, you should end up with -1/7 times x. In the next one, -5/3 times x. And in the last one, 1/4 times x. So here's an example of a division equation. It's division because the variable is being divided by a number instead of multiplied by a number. However, we're going to change all division to multiplication, just like we change all subtraction to addition. So remember, if we had an equation like x minus 3 equaled -5, we would change this to x plus -3 equals -5. Well, the same idea applies here. So we just practiced rewriting division as multiplication. So what would you rewrite x divided by 3 as? 1/3 times x, right? So now this is a multiplication equation instead of a division equation. So again, we will not be writing division, we will be writing multiplication. Now we're going to work with the inverse property for multiplication, which is which property? Reciprocal, right? So when we were dealing with multiplication equations and solving those, what did we do to the left-hand side in order to get x by itself? We multiplied by the reciprocal of the number that's being multiplied by x, right? What number is being multiplied by x? 1/3. So we're going to multiply by the reciprocal of 1/3, which is what? 3. Very good. So if we multiply by 3, on the left-hand side, what do we have to do to the right-hand side? Same thing to keep the equation balanced, right? So we're going to end up with 1 times x on the left-hand side, which is our goal. With multiplication, we want to end up with 1 times x because that equals x. That's how we get our x by itself. And then negative 4 times 3 is negative 12. So x equals negative 12. And we can check this like any equation. If we go back to the original equation before we changed anything and substitute negative 12 in the place of x, negative 12 divided by 3 does indeed equal negative 4. Now I'd like you to try solving both of these equations. Be sure that with the division equation, you change it to multiplication. And for both equations, the way I want you to solve is to multiply by the reciprocal on both sides of the number that's being multiplied by your variable. In this first equation, I multiplied both sides by negative 1/3, which is the reciprocal of negative 3. And I cross-canceled on both sides, and I end up with 1 times x on my left-hand side and 3 times negative 1 on the right-hand side. So x equals negative 3. Again, it's okay if you skip this in-between step, which shows the identity property, if you would like. That's up to you. The next equation, I have x divided by negative 5 equals 6, which is the same as negative 1/5 x equaling 6. I multiplied both sides by the reciprocal of negative 1/5, which is negative 5. I end up with 1 times x equaling negative 30. Again, you can skip this identity step if you'd like, and x equals negative 30. I do want to see all the other steps, however, in both problems. In this next problem, you're going to have to add your like terms over on the right-hand side before you can start working with the problem. So go ahead and give this one a shot. The first step in this equation, you should have changed division to multiplication, and you should have changed subtraction to addition. Then you can start working with the equation. So on the right-hand side, you need to add negative 8 plus negative 5 to get negative 13. Now we're going to multiply by the reciprocal of negative 1/3, which is negative 3. And if you do that on the left-hand side to get rid of the negative 1/3, you have to do the same thing on the right-hand side to keep the equation balanced. Now I want you to keep in mind that reciprocals always have the same sign. So since we're multiplying the x by negative 1/3, the reciprocal has to be a negative 3. So just be careful with that. Don't lose that negative. On your next step, you get 1 times x equals 39. So x is 39. Again, you can skip the identity property step if you'd like. But I need to see all these other steps. Now in this equation, you have a multiplication equation, and you have a fraction on the other side. It's really not that hard. You're just going to multiply by the reciprocal of 2/7 on both sides. Make sure you cross cancel since you're going to end up with a fraction times a fraction, and simplify. Give that a So the first thing I did is to make very clear that I have 2/7 times b equals negative 8/5, and then I multiplied by the reciprocal of the fraction that's being multiplied by b. Since the fraction that's being multiplied by b is 2/7, then I'm multiplying by 7/2 because reciprocals will give me a 1, and that's my goal, is to get 1 times b. Since I multiplied the left-hand side by 7/2, I'm multiplying the right-hand side by 7/2 as well. And I cross-cancel everywhere that I possibly can. And I end up with 1 times b on the left-hand side, and negative 4 times 7 in the numerator of the right-hand side, and 5 times 1 in the denominator, which gives me b equals negative 28/5, and that simplifies to equal negative 5 3/5. Again, you can skip the identity property step. You can do this step in your head if you'd like, or you can write it out, whatever's easier for you. Now I also did a check step here to demonstrate how you would complete a check step with a fraction. First of all, you would leave it improper. You wouldn't put it back into the problem as a mixed number because you're just going to have to change it to improper again anyway. So here is my check step. Here's my original equation. So I have 2/7 times my answer. Here's my answer, negative 28/5 equals negative 8/5. I'm going to see if this is true. I make sure I cross cancel to make my multiplication easy. 2 times negative 4 is negative 8. 7 times becomes a 1, and 1 times 5 is 5. And I end up with negative 8/5 equals negative 8/5. So I know that my problem has been solved correctly. Try this next problem and check back. For this next equation, I want to make sure that I change all subtraction to addition. There's no division, so I don't have to worry about changing that. I end up with negative 2m plus negative m. Those are same sign, so I'm going to, or like terms, so I'm going to go ahead and add like terms. They are also same signs. So negative 2 plus negative 1, remember negative m is the same as negative 1m. Negative 2m plus negative 1m is negative 3m. So I end up with 300 equaling negative 3m. And I like to change my equation so that my variable is on the left-hand side. So that's what I did in my next step. And then I multiplied both sides by the reciprocal of negative 3, which is negative 1/3, and I cross-canceled. I end up with 1 times m equals 100 times negative 1. So m equals negative 100. Again, you can skip the identity property step, this step right here if you'd like, but I need to see your other steps. You can actually, if you'd like, go from this step to that step as well. So you don't have to show me this in-between step here. That's up to you. Next, we have a quick review of working with squares and square roots as equations. I'd like you to try these problems, please. Make sure that you square square roots, and therefore you square both sides. So the first one is x equals 16. The second problem, x equals 49. And then if you have your x being squared, the inverse is to square root, so you square root both sides. And in the first problem, x equals 4 and x equals the square root of 3 is the last problem. Remember, if you can't take the square root of the number, if it's not a perfect square, you just leave it. So let's review. When a number is being added to x, you're going to use your opposite property. So in this example, we would add 6 to both sides. When a number is being multiplied by x, you use the reciprocal property. So in this example, we would multiply by the reciprocal of negative 3/5 on both sides. And this is what we practiced in this section. When x is being squared, we take the square root of both sides. So in this example, we would take the square root of both sides. When x is being square rooted, we square both sides. So in this example, we would square both sides. And of course, whatever you do to the left side, in order to get the x by itself, you must also do the same to the other side to keep the equation balanced or equals. And this is the big picture of understanding how to solve equations. You're always using those inverse properties to get x by itself.